In this video I'm going to share what I've learned about using AI and LLMs to reliably scrape data from web pages. I'm going to show you how to implement this in TypeScript, how to implement it in Python, have a little sample project, and then some code to go along with it linked below. Let's get into it. Okay, first let's look at a sample project scope of where you might want to use this. This here is inspired from a project I've been working on with a friend where we're tracking changes to personal details of government personnel over time. So for the sample here, what we're going to do is go to a website's profile page that has a site directory. So if we look here at this law firm that we're using just as a sample, you see that they've got all of their partners here. And then if you click on them, it opens up their profile page. So we see a sample lawyer here. So the scope of what we're going to work on is go to this page, get all of these URLs, and then go to each individual URL and get some key details for the employees. Now the project we've been working on involves doing this over 10 different sites, and you get a total of about 500 people, but we're just going to run this on one page here. Now, requirement here is that we must be able to deal with site structure changing. So we're looking here, we know where everything is on this site, but we need to be able to deal with if this site structure changes, or if we go to a new person and they've got different things, a different layout. That is where normal or existing scraping methods don't work very well, and where AI really shines, because the LLMs can pick out even if the structure changes. And then a fifth requirement is that for us anyway, for running across all 500 people, we had to be able to run this in under $2 a time. So that knocked out some different ways that we could do this using some no-code tools, which would have cost way more than $2 per time. So the method I'm about to show you, we managed to run this down to just over $1 to get 500 people, and there are even further things we can put in place to reduce that cost. We now jump over here into code. I'm going to start with TypeScript because it's what I'm most proficient in, but I will be showing you Python in just a little second. There are, on the left hand side here, we see lots of files because the project that we've set up is a database and API and dashboard and blah blah blah. For this here, all we care about is this one file, so we're going to reduce this down. And this is what we'll release as well. It contains everything we need for how to scrape specific websites. In here, we've got three main functions. We've got fetching URLs for all of the employees. We've got fetching details for a single employee. And then we've got scrape all employees, which combines them together, just runs fetch all and then iterates through. So fetch URLs for each goes to here, gets URL for each employee, and then fetch employee details goes to here and gets the details that we require. Nice and simple. If we take a look into here for fetching URLs for all of the employees, the two key takeaways here that I've learned is to get the page into Markdown and then use a JSON schema. If you take nothing else away from this apart from that, it is get the page into Markdown and then use a JSON schema. So first of all, getting the page into Markdown, I've run this in TypeScript using JSDOM and turned on service. There's a ton of ways to do this. We get into Markdown, and then for the JSON schema here, we are just going to get an array of URLs. I've decided to name them with employees because we can only have an object. We can't just return it in an array. And then specifically stating that we're getting URLs. This is just a bit more extra naming because we're about to pass it to an LLM. It seems to work very well. We come down to our schema. We're using with structured output. I've decided to use long chain here because it is easy to switch between different JSON schema methods. So a few LLMs, especially OpenAI that we've got here, has got JSON schema or JSON mode, or we can use a function toolkit. There are different ways to do it, and long chain makes it really easy to switch between them. As far as we were to run this with a normal SDK, we'd have to completely change the code. So passing that in, for the LLM, I've went for really low temperature because we want this. We don't want this to get creative at all. And then for the model, managed to get this running with 4 omni, so it's kept the cost down really quite well. So we look in here that we're naming employees URLs is the name of the structured output that we want to return. Again, just something that's nicely named so that LLM can understand. I'm including raw because I want to get all of the details, but from OpenAI, just tokens and things like that, just for logging. This is not really required. And then when I come to invoke, As you can see here, I've kept this prompt really nice and simple. People like to really overcomplicate prompts. I tried with something extra and long and shortened it down until I got good results. All I've done is told it we're about to pass the LLM a markdown of a web page. It includes a list of employees with their name and URL, and then ask it to extract out the URLs in JSON format. And that's essentially it. 3 lines, nice and simple, and this has worked really, really well every single time. And then, so that's for fetching all the URLs. Doing employee details is nearly the exact same. We just have a more structured schema. So because we're trying to pull up more things, name, bio, role, email, array of practice, specialty sectors, and then use the same thing, JSON schema. This is the one that has worked best for me. And then again, a nice and simple prompt. I've included each detail that we're trying to extract. You could probably run it without this, but that worked really well. And I've passed the base URL for any things where it's trying to fetch URLs. I found this to be useful rather than it trying to return forward slashes. And that's essentially it. What we're going to do is run this. And that'll log results here. But in the meantime, let's go and look at the exact same thing in Python. So I've essentially implemented, because LangChain is a very similar API between TypeScript and Python, essentially implemented the exact same thing, but in Python. The key difference is here is for fetching as Markdown. I've used beautiful soup and then HTML to text. Again, probably a ton of ways to do this. And then for the schemas, I decided to use Typescript instead of Pedantic because it was easier to turn into for logging at the end. But play around. If you're used to using Python, you're going to know yourself which you prefer. But again, I will release all of this code, and you can see the similarities here, that we're essentially just doing the same. Structured output, returning them. Structured output, returning. Nice simple prompt. And that's that. If we come over here and look at, move my little face, look at our log, we can see with that really simple prompt, we've managed to pull out all of these key details. I think it was Robin that we looked at here. And we've managed to get all of these URLs. Cool. That's it. If you've got any questions on scraping with AI, if you've learned anything different to what I've got here, then please reach out, let me know. Ciao.